Hi everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be learning about lenses, and this is for GCSE Physics triple scientists. If you do enjoy this video, feel free to subscribe, join the community here. I do upload videos every Sunday, 12 midday UK time. So if you would like to be part of it, feel free to click the bell so you get notified of those uploads. Also, thank you so much to everyone for your support. I really do appreciate it. If you've liked the video, shared, commented, and of course subscribed, thank you ever so much. Let's get started and discuss this idea of lenses. So we're going to talk about convex lenses, concave lenses, and we're also going to consider how we draw ray diagrams for those lenses as well. So first of all, what actually are lenses? Well, they are a transparent block, which means that you can see through them. And you've probably experienced a lens in your lifetime before. You may even be wearing them now if you wear glasses. And lenses, like I say, can basically be everywhere. So we see them in microscopes, telescopes, cameras, magnifying glasses, all over in different objects. And their job really is to magnify images or make images smaller or even project images as well. So they're really, really useful. But they do this because of the idea of refraction. And that just means light bending due to a different medium. As it travels through a different medium, say it's traveling through air and then it moves into glass like this transparent block or this lens, the light actually changes speed and it starts to refract and bend. And we're going to explore this idea in this video. Now, like I said, there's two types of lenses. One is called a convex lens, which has kind of a swollen shape, whereas a concave lens has a more inward shape. And the way I like to remember this is concave has the word cave in it. And as you can imagine, a cave caves inwards. It's the same in a concave lens. So we're going to discuss how they actually work, but just in short, convex lenses actually cause light rays to converge towards a focal point, which means come together, whereas concave lenses actually cause the opposite. They cause light rays to diverge from a focal point, and this just means spread out. So let's look at this in more detail. So just before we do, let's just clarify some key terms because these three words often come up in different ways in physics, and often they can be actually used to mean the same thing, and we don't want that. We want to make sure we know what each of these means. So reflection. If we are to look at a ray diagram here, we've got a straight horizontal black line. This is just the lens itself, and the red line represents the light ray. Reflection just shows you that we have a light ray going into a medium and then back outwards and is reflected off that medium. So the direction changes, it bounces off a barrier, as you can see here, at the same angle. Refraction, which we're going to focus on today, shows us that the wave travels through the medium like a lens and then it travels at a different direction or bends, which is what refraction means. And this is because that light ray changes speed as it moves through that particular lens. Diffraction, however, is slightly different, and this is how we are able to see the whole spectrum of colours or the rainbow that's found within white light. And diffraction just means that the light is dispersed because each of those parts of that light, each of the spectrum actually diffract at different angles, at different speeds. They move through the light. The light moves at different speeds through the prism, and that causes that spread of different colours there, and we get those different wavelengths of light as well. So let's look at convex lenses. Like I said, convex lenses, they are able to cause a convergence effect or converge all those light rays to one focal point, which we call the principal focus F. And as you can see, there's also a nice dotted line in black here. And this is the normal line, which you've often see represented on ray diagrams, or if you've done any work at Key Stage 3 with light as well. And essentially that dotted line just shows you that the light rays are parallel to this normal point, which is what that is referred to. So how do we actually draw a convex lens if we don't physically draw the lens, as you can see on the left? What we do is we represent it with an arrow that's got two ends that are pointing away from itself. And the way I like to show this is actually if you were to draw those arrows, if you were actually to draw part of that arrow all the way down to the other one, it would actually make a nice curved shape. So that's a good way to remember it. Now, as you can see, we also have something called the principal focus focal length. And this is basically due to the midpoint of the lens and the distance from that midpoint to the principal focus. And that's what we call the focal length. Now, the focal length will become important later on in the video, but I just wanted to point that out here. So here's the other type of lens. We have a concave lens, which, as we know, is concaved inwards or curved inwards. And this causes the light rays to diverge. So they actually spread apart, unlike in a convex lens, which actually causes the convergence of light. So they actually go to a physical focal point. Now, you might be thinking to yourself, okay, well, where do they come from? Well, we know that the light rays are moving at a parallel position at the beginning, and then they start to diverge. However, scientists can actually suggest that they must be coming potentially from a principal focus behind the lens itself, way before. And we've drawn that in here, as you can see. So the principal focus, instead of it being on the after effect, if you will, as we would have seen in the convex lens, the principal focus is actually beforehand, and that's where those light rays are actually coming from originally. We've drawn those in, but often we wouldn't be able to really say that's exactly where it is. This is just more of a prediction. But we can definitely use this to determine the focal length. And like I say, the focal length will become important later on. But as you can see, it's just from the distance from the principal focus F to the middle of that lens. Now, notice the lens itself is represented slightly differently than a convex lens. The arrowheads are pointing towards the center now, so they've been inverted. And that's just a way to show you in the exam, if you are expected to draw it or you are expected to label it or something like that, just be aware that convex lenses and concave lenses are given slightly different representing structures. So just be aware of making a note of that one. So these two lenses, convex and concave, because of their different abilities to either diverge or converge the light rays, actually cause the image produced to have a certain characteristic. And there's three different categories and three different things that can occur because of those lenses. So the first thing is the image upright or is it inverted? Is it upside down? Is the image magnified or larger or is it diminished? Is it smaller? And is the image real or virtual? Now, often students will kind of find the real versus a virtual image confusing compared to the other two categories. And this is because often we think of real things being what we see in real life and virtual things being what we see on, say, social media or the internet. Now, that is not what we're referring to here, which kind of confuses things, but let me explain. So a real image is an image that we can see projected onto a screen. So this is often used in things like cinema, that type of thing. However, a virtual image is what we see to appear behind the lens. And I'm going to show you some examples of this, but I would make a flashcard on this just to help you guys out in the future when you come back to revising this. That's what we mean by real and virtual. Real is just you can project the image on a screen, and virtual is the image appears to come from behind the lens itself. So let's see this in practice. So let's see how they could ask you to use convex and concave lenses in the case of ray diagrams. So this is showing the rays of light and how they actually produce an image based on an object that is being viewed through a lens. So we have a convex lens here. We'll get onto concave in a moment. So what do we need to do? The first thing you want to do is place the object that you are using 2 focal points or 2F away from the lens itself. And I've simply done that by drawing the lens, which is convex. So we have an arrow that's essentially double-sided and you have the arrows pointing away. That's representing the convex lens. And I've used a nice straight ruler to actually draw the focal points as well. Now, they'll probably give you this information in the exam. They'll say, the focal point is 1 centimeter away from the lens itself. That's what you would need to draw in on either side. Therefore, 2 focal lengths will be double that amount, so 2 centimeters. And you can add this into your diagram. So once we've done the drawing of the lens, we've drawn out the focal points. We also have that straight line, which I represented with a dashed line beforehand. Sometimes this is called the normal. Sometimes this is also called the principal axis as well. Either way, it's that nice horizontal line that goes straight through the middle of that lens. So then what you want to do is you want to place your object on 2 focal points away from the midline of that lens. And that's point number 1. And what you're going to do is draw a nice straight line from the top of that object straight through the middle of that lens where the cross is. Imagine it's like an axis on a graph. So you're going to go straight down like I have done here with that pink line. After that, you're going to draw a parallel line that is parallel to the principal axis. So it's nice and parallel, as you can see in point number 2. And that goes across and hits the convex lens, as you see here. The third thing you want to do is draw a line that is refracted through the principal focus. So as you can see, number 3, the principal focus is really important here because that's where those lines are going to diverge through that principal focus, as you can see here. Now, where those 2 lines meet from point number 1 and point number 3 is where the top of that image is going to be produced. And as you can see, this image is now magnified. It's larger than the object was at the beginning. It's also inverted as well. And because it's a convex lens, it's actually a real image as well, which, remember, just simply means that you can project it on a screen. So that is the sort of thing you would see if we were 2 focal points away, if that object was 2 focal points away using a convex lens. So what happens if we were to move the object further away from the lens itself in a convex lens? As you can see, it actually becomes smaller, which we would refer to as diminished. It becomes smaller in size. It's still inverted, it's still upside down, it's still real, it still can be projected on a screen, but it's much smaller. And the reason for that is because the angle of the ray is actually more extreme, and you can see that in this case. So let's go through the steps again. All you need to do is place the object at a specific point. In this case, it's further than 2 focal points away. or 2F, and then you want to draw a straight line which represents the ray of light from the top of the image through the middle line. And I would recommend you make that line as big as possible, so when you're drawing this you can see that nice convergence quite easily. You then want to draw a parallel line across from the top of the image, and this is parallel again to that principal axis as I mentioned before. And as soon as it hits the convex lens line, you want to then draw a straight line down so it goes through the first focal point, and you can actually see that I've done that here. And then that shows you that the light has been refracted. It goes and converges with that other line that we drew at the beginning. It goes through that principal focus, and we can then draw our image at the top. As you can see, so where that line crosses, we can draw the top of our image, and that's what we see here. So it's still diminished. It's diminished, it's still inverted, and it is real, of course, as well. But let's have a look at how this changes if we change the type of lens. So let's use a concave lens this time to see how the image changes. And remember, a concave lens will have a slightly different symbol than a convex one. So you want to make sure those arrows are pointing inwards as opposed to outwards as we had before. And that represents our lens in this case. Of course, as well, you want to draw the principal axis, which is a straight horizontal line going through the lens in the center. What you want to do with a concave lens is you want to place your object you want to see the image of greater than one principal focus away from the lens, and then start to draw a straight line through the middle of that lens from the top of the object downwards. And you can see that with the pink line here. The second step you want to do is to draw a horizontal line which is parallel from the top of the image and is parallel to the principal axis. That will then hit the lens itself, as you can see in point 2, and it will start to be refracted. Now, the refracted angle will come from the position of the principal focus. So I've drawn a dotted line because we're not entirely sure that's where it comes from, but the principal focus we can use to draw that line here. So that's what you want to do, a nice dotted line to help you make that correct angle for that third line, as you see here. Then what you want to do is use this line that you've drawn, the dotted line, to draw the image that you see. And as you can see, this image is now diminished, so it's smaller, it's also upright, and it's a virtual image. So virtual, remember, means that you can't see it projected on a screen, and we can actually use a screen to see if we'd be able to see this, which we wouldn't. It appears as though the image itself is coming from behind the lens. So that's the difference in these cases. So as a means of a summary to help you with your own revision, because I know what I've discussed is quite a lot of information, I did just want to point out a couple of key points that will really help you when you come back to this topic in general. So in the case of a concave lens, the image will always be diminished, upright and virtual. That just means the object compared to the image will be diminished, it'll be smaller, it will be the same way up, and it will be virtual, meaning that you can't project it on a screen and it appears as though the image is coming from behind the lens. That's the kind of terminology you want to use, is these 3 words. In the case of convex lenses, however, it really depends on the distance the object is from the lens and therefore what image you will see. So if we have an object that is greater than 2 times the principal focus, or greater than 2f, the image will be diminished, it'll be smaller, it will be inverted, and it will be real, meaning that you can actually project it onto a screen. The only time it will be magnified is if the object is 1 to 2 principal focuses away from the lens itself, and that is when the object becomes larger. But again, it will still be inverted, it will still be real, and that's the key points you should know for those different lenses. So final tip for you with this topic is lots and lots of practice of past paper questions. I really do recommend the more practice of this, the better. And also with applying yourself to this topic as well, make sure you're using a pencil, make sure you're using a ruler. The amount of times I see students who just forget this simple step and then make a mistake, and it's really hard to then correct when you've drawn it in pen. Don't make that mistake. You guys know what to do. Pencil and ruler all the way. And if you make a mistake, that's fine. You can just rub it out and start again. I hope you guys did find that video helpful. If you did, feel free to let me know in the comments section. If you'd like more triple content, or you'd like me to make my triple content into an entire triple playlist, please do let me know as well. If you'd like more content from me, I've linked some videos for you. In the meantime, I've been the GCSE science teacher and you have been curious. Thank you so much for your time. I'll catch you in the next one.